My name's John Vogman. I've been a product designer for over 11 years, and I've built a lot of prototypes. Today I just want to talk to you about the basics of prototyping. What is it, how it can be applied to your product design process, why it's useful, that kind of stuff. When people think of prototypes, you probably think of what I would call a final prototype. This is that vehicle driving down the street covered in a obscure car wrap so you can't tell what the form looks like. That would be a car that's already fully designed and they're just doing some performance testing on the back end before it gets released. I would call that a final prototype. You might think of a sculpture that looks really beautiful, but it's not quite made out of the final material, but it's basically perfected in terms of its shape. I would call that a final prototype. But in reality, there are many prototypes that come before that one along the way. You start off with just the most simple possible type of physical object to learn from, and that I would call a proof of concept prototype. You can prove the concept of your overall design, or just of the aesthetics, or just of one of the sub-mechanisms within your component, and you can have different proof of concepts for different pieces of your product. A proof of concept is made out of the simplest materials you can think of. Really just anything you have on hand. I would say tape, cardboard, paper, just whatever kind of scrap wood or parts you have laying around. That is what you're going to make your proof of concept out of. And that's just to get general feelings for the scale and form of your product. This is before you get into the more well thought out prototypes along the way. Just as one example of a proof of concept prototype, this is about as simple as it can possibly get. This is a piece of paper with tape on it. You can see that it has it's pretty crinkled up because there's different fold lines on it. What this was for was there was one aspect of a product that involved a flexible fabric material. It was actually for a tent that had to go around some odd shape. We couldn't really visualize how the tent fabric would fold in on itself using sketch paper or a whiteboard or CAD modeling. Those programs and that type of sketching isn't the best for free-flowing organic materials, especially like textiles. So we just got a simple piece of paper. We wanted to come up with some quick ways to see how this thing would fold up. How it would fold up might actually drive design decisions down the road on the kind of structure that had to work with the corners of the product. So some tape and pieces of paper, and about an hour later, and we had a good understanding of how it might fold up. That helps save a lot of time down the road. So even though that is an absurdly simple prototype, I would say it was very useful. That's going to be the driving theme of this video, is that the whole point of a prototype is to be useful. You should learn something from it in order to make the next version, the next prototype. You might end up making 2 prototypes. You might make 10. You might make 100. It really depends on the difficulty of your product, how many parts are involved, how many subsections of the product need to get individually prototyped before the whole thing gets put together in one. It might come down to your budget and your timeline needs. This is a really critical phase of the design process, so I wouldn't advise rushing it, but there are, clients and people out there that are working on a very lean budget or simply don't have the patience to sit through as many prototypes as they really should to get to the final and bring them to production. It might also have a little bit to do with the competency of your designer. Now, that's not to say a better designer will necessarily create less prototypes. It's just that on average, I think that might be true. You could think of the best designer in the world going through 100 prototypes of something to get it to absolute perfection. Now, there's nothing to say that amazing designer should have only done that in 5 prototypes. Maybe it takes more depending on what the product is. And on the opposite side of the coin, you have a very low quality designer that might only use 1 or 2 prototypes, and they rush through the process. They don't learn as much as they should. They don't iterate based on what they found through prototype testing, and they rush it to market, and then it doesn't perform or look as good as it could. So I wouldn't go into your process for your product expecting any certain number of prototypes. I guess the bare minimum would be 1, and when you start getting up over 20, it does start to get a little excessive, and maybe at that point, you really don't need to have that many. So I'm going to show you a few different types of prototypes I have laying out on the table in front of me. You'll start to recognize a theme here. We really like to use 3D printing for a lot of what we make, but sometimes we'll use hand tooling and a few other methods that I'll go over too. So let's see here. We talked about the piece of paper. That is as simple and as crude as it can possibly get. Kind of one level up from that would be just to purchase this foam from your nearby hardware store. This isn't a good example of it because it's already cut down, but it's just this large pinkish purple foam. It's used for insulation, very cheap. You buy it in these big long sections at the store, bring it home, and you can form the shape of your product with this foam for very cheap. What we typically like to use is some kind of a wire cutter. This one's a real simple, cheap one that you can plug into the wall. The wire gets hot. You should wear a gas mask. You don't want to breathe in foam vapors as they're burning. And then you just carve out the shape, kind of like a sculpture. That's a very simple way to get a form in your hand that's actually pretty stable, and you can get a good sense of ergonomics and a few other things just off of a few minutes of carving a piece of foam. I don't have any here to show you, but you can look up a thing called modeling clay. It usually comes in the color gray, and it's just like clay that you've messed with before. It's a little tougher than Play-Doh consistency, but it's not as runny as the clay you use to throw ceramics. So you can just get real quick ideas in front of your hands using that modeling clay. So right in front of me, I have 5 different little headlamp concepts. This was very early on in the process. We wanted to figure out where the buttons should be on the headlamp. So they could be in a lot of places all around the body of it. We also wanted to figure out the overall size of the headlamp and to see whether it was too big or too small. And we wanted to play around with the dial size as well, or the lens diameter size. Now it depends what industry and you're making your product for, as well as who your target market is. That'll drive really all the decisions you make along the design process. But we made the decision early on, just for this product, to go about it a little bit backwards and approach it with the aesthetics first, and I guess user experience. The placement of the buttons is really critical to the operation for the industry we were making this for. We needed to prove the concept that it could be reached by either hand, one-handed. That was one of the selling points of the product, as well as that this could be installed or put on your head upside down, whether it be on accident or because someone's ambidextrous and they use their other hand more frequently. And the buttons still needed to work with left and right-handed people. The dial also had to be big enough that you could grab it without your hand missing the dial, and not be so small that when you're wearing gloves, you wouldn't be able to turn it. So there were just a lot of considerations we had to think about, and really could have been any shape you can imagine. So the first thing we did was we sketched out a ton of headlamp physical concepts, and then we kind of whittled it down to our top 5. Then we went to our in-house 3D printer, which is just a simple desktop 3D printer that really anybody can afford and learn how to use. And we printed it out of some really cheap PLA filament material. This is about the fastest, cheapest way you can 3D print something, and you don't need to worry about a ton of waste or a ton of cost involved with that. So once we got these in our hands, we were able to obviously eliminate a few, and a couple of them were still top contenders. But this was just a first go at the aesthetics of this headlamp. Back to the foam shape, this was actually going to be for a handheld device, and we needed to see how good the ergonomics were for holding it, how your hand wraps around it, where your fingers are placed, regardless of which hand you're using to hold it. Now, we thought that was an okay shape, and we cut out other shapes too that didn't make the cut. But we wanted to try something a little more unique with the aesthetics, something that was a little harder to carve with the hot wire cutter. So we modeled it up in CAD, and we 3D printed this shape, which was based off of this. And we were wondering if this helical or this interesting curvature shape would hold well in your hand. So we did a quick 3D print of it. It's hollow. It doesn't have any of the buttons or any of the other features involved, just to get a hold on it as well. So this was useful. Again, that's the whole point of these things, is to learn something as fast as you can to move on to the next prototype. This isn't all about speed to market, which is obviously a nice thing. If you can move as fast as possible, you get your product on the store shelves earlier, and you don't miss out on selling seasons. But it's also just flat out efficient. You want to, as soon as you get to a point with one prototype where you've learned as much as you can from it, you should move on to the redesign and iteration based upon what you learned and go straight into the next one. Now, there are simple 3D printers like what we have that print in some robust materials like PLA, ABS. My favorite is to print out of nylon because it's real strong. It's only a little bit more cost for the filament, so in my view, it's usually worth it to print with nylon, and that's our go-to. But you can also have different kinds of at-home 3D printers, and these can be, there's a few different names for them, but I call them resin printers. It's where you have a UV curable resin, and it shines a UV image into the resin bath and cures it one layer at a time as it builds up. Now, the nice thing about resin is you can get very intricate, difficult to make shapes that are thin-walled, that have really fragile and frail sections that you can't do as well on a standard 3D printer. You can do that with a resin printer. There are certain really nice resin printers too that you can print with different materials. This is a miniaturized grip for handlebars, maybe for a children's bike, and you can see that it squishes down, so it's a special kind of material. You gotta buy the nicer resin printers to be able to do that. But that's super useful to use that kind of a printer when you care about the aesthetics or the exact fit of a product. Now, the downside with most resin printers is that they're super frail and weak. This one has a crack in it just from me handling it gently. So the material themselves is not very good for function testing typically, especially if it's a mechanical function or a mechanism that has to undergo different forces and loads. So different printers and different methods for making different aspects of the product. That's what you'll find. As you go along, you'll get better at picking which type of device or machine is best suited to make that part for that type of testing it needs to go through. Sheet metal is actually very easy to prototype from. You just design it in a CAD software or whatever your software of choice is. And there are different online places. If you don't have an in-house water jet or laser cutter that can cut through metal, there are different online places. One of them, my favorite right now, is a place called sendcutsend.com. You just send them a little DXF file of the outline of where they want to cut. This is aluminum. They can cut it and then apply any kind of finish you want, whether that's powder coat or anodize or whatever else. They can install hardware. They're not sponsored. They're just an awesome resource. And so they can do that for very cheap. I'm talking in the tens of dollars, and then mail it to you for free. I think there's currently no shipping. And it's just super useful to quickly iterate with sheet metal parts using online sites. There are certain online sites or machine shops that are not fast though. And that is, for example, if I wanted to make this headlamp body out of a pure block of aluminum. I don't know why I'd want to do that, but let's just say I do. That would need to be CNC milled at a machine shop that works with metal and has these pretty expensive machines that can do that. That is going to be very expensive, and it's going to take a lot of time to set up and then a lot of time to wait for it to get done. I mean, this is going to be hundreds of dollars for this size of a part out of some generic aluminum, you're probably going to spend about 2 weeks writing up your quote requests and sending them out, and then having back and forth with the machine shops, and then deciding on a place to go with. And then probably anywhere between 4 and 8 weeks to wait for this part to get in hand. So you're talking 2.5 months for a little thing that you could have had 3D printed in an hour. So you got to be smart when you go about making the parts and decide what's really needed at that time. So proof of concept prototypes, they're your super early stuff. Paper, duct tape, cardboard, super basic. Everything in between that and a final prototype, which is the last kind that there is, I just call those iterative prototypes. They might go by different names, but there could be a lot of these in the middle, and it gets very murky on what it is that we're talking about here, how well designed that product is. The iterative prototypes that are closer to the proof of concept ones are going to be very crude and ugly, not something you're really proud of to show off, but you still learned from. And the ones closer to the final prototype might be deceivingly beautiful. They might be very close to what you actually want to bring to market, but they're still not really a true final prototype. So I want to show you a couple more examples here. This is a hinge. It's part of an overall product that is much larger than this, but we only wanted to test the subassembly of the hinge to verify that it worked. It's kind of a proprietary, interesting looking hinge that we hadn't seen used before. So I printed off 2 different bodies out of this high quality resin printer that has almost no layer lines visible and is very smooth, and then got a little stainless steel pin to put in as the hinge pin to test the operation. Eventually we got it to work, but this wasn't the first one we had to make. This is probably the 4th or 5th, just for this hinge subsection. So again, you never know how many prototypes it's going to take until you go through it. Sometimes you want to do some semi-functional testing. So this product actually is missing a bunch of components and it's not fully put together correctly, but it gets the general idea across of the 1-to-1 scale of the product, as well as the aesthetics, as well as the feel in your hands. And we wanted to test the spin motion and see how smooth it was to spin and whether it got off its concentricity and went around in an ellipse rather than a perfect circle. So we were able to do that again with PLA on the desktop printer for very, very cheap and very quick. If you buy a slightly larger 3D printer, you can print larger objects. Depending on your product, that might not be needed. I think a lot of consumer products nowadays can be printed on just a standard printer, but they do make bigger ones that can print larger pieces like this. You can even get the size of a motorcycle helmet printed on some at-home printers, a little more costly. But this became useful when it came time to print this at 1-to-1 scale and then install parts to this. This was part of a much larger assembly with electronics inside, just to make sure that everything would fit. Your first step to make sure things would fit could be on a CAD modeling program, but getting things in your hands, you'll always find something that you missed in 3D in the model. That's something interesting that I've found out over the years is you can get it perfected in your CAD model program. It could be, in your mind, 100% perfect. And you could think, well, do I even need to prototype this? Is it worth the time and effort? And the truth is basically always yes. If you go to the trouble to create your prototype based on the CAD models that you thought were perfect for your part, and then it ends up being perfect, great. You've now confirmed that you're a great designer and you did the impossible and made something work perfectly before it ever got prototyped. That is very rare. In fact, almost never happens, no matter how good of a designer you are. But what's most likely to happen is you're going to notice 2 or 3 or 10 different little things from the physical product in your hands that you couldn't think of just looking at it in a 3D model. For example, unless you're using advanced simulation methods and you're very experienced with this expensive software, you're not going to be able to understand how certain loads affect your product. Let's say you have a device, and then over here there's a heavy weight pulling down on this. In the CAD model, everything stays perfectly flat, but then in reality, it causes this part of your product to sag down. That's something you noticed in reality. So the effects of gravity and forces and loads, as well as actual friction that your parts will experience as they interact with each other, that's stuff you can really only get a good sense on if you've been doing this for many years or you make a physical prototype. So 3D printing is one of our big go-tos, but there's a few other ways that we like to use, and sometimes we use kind of a hybrid model. Like this is a scaled down version of the back of a truck vehicle with an overhead top rack. It's got a rear window that's open. It's got the tailgate down. It's got something on the side. So for this is 3D printed nylon. We've got a section of aluminum we cut and we hot glued in place. We have cardboard and we have tape. I mean, just very, very simple and easy. You might have components in your product that need to give it a sense of waterproofing or something that is flexible and non-rigid. If that's the case, what you're going to want to be able to use is usually a two-part mix of some kind of silicone or other rubber. We tend to like to use silicone. It's just kind of higher quality and gets better results for testing, and it's only a little bit more expensive than the cheap kinds of rubber. But when you go to make your silicone part, if you want it to match what it looks like in the CAD model, you might have to create a mold. So this is a two-piece mold. You would pour the silicone liquid mixture in there, put the top of the mold on, and then clamp it down in place, let it dry. That's a little bit more of an advanced technique and only important if you're dealing with interesting shapes that you can't easily make out of foam products that you can cut. That would be your go-to, is to just buy a sheet of foam and then cut it to shape with scissors if that's possible. Here's another just ergonomic print of something that had to be a certain size. It had to be roughly purse size, and you needed to be able to grab it with one hand or two without it being too big or too small. So this is purely an aesthetic 3D print. Again, it took a few hours and was worth every second to figure out how that would feel in your hands. You might be judicious in the size of print that you go with. This is actually the same part, but this is only printed to an inch tall, and this is much taller. This took about 30 minutes to print, and this took about 9 hours. Now, if you're only checking the diameter, or if whatever you're testing has to do, it can get away with only being that thin, then you should only print it that thin. This just saves time. It helps you iterate faster. And then later on, when you have to make a more complex version of that, go ahead and print the full size. Okay, so sometimes you're not only prototyping the product itself. Sometimes you're prototyping the environment. Oftentimes your product won't just be in someone's hands. It will interact with something else in some way. So back to this truck, we were dealing with something that mounted to the back of the vehicle, and so we needed to print a scaled down version of this with a matching scale version of the product to see how it would fit. It was just much more practical than doing a one-to-one scale prototype of this very large equipment. Here's another one. We had a rectangular product that had to go inside of this rectangular hole after we put this foam liner tape in, and it had to expand into place. So what the cheapest way to do this would be to take some 2x4s and nail them together. And I think for the very first prototype of this, we did do that. Eventually, though, we knew that the hole size that our product was going to work in was going to be this size. And the client decided that they wanted to use this material as a display at trade shows that they went to. They ended up making a bunch more. This is just an old one. But because of that, the client decided, well, I want this made out of high quality material. So we went with this real strong, thick, solid oak wood, and it was just cut very beautifully, which was a little unnecessary for the prototype, but perfect for displaying at a trade show. So it was kind of a double whammy there. When you start to inch your way closer to the final prototype, you're going to want to check that your mechanisms work the way that you expect them to. So you start dealing with not just aesthetic pieces, but maybe multifunctional mechanical pieces. Here's one, here's another one. It's not obvious what product these things go in, which is good. All I want to talk about is that you can do different things with the same prototype. So for example, this product has 3 different functionalities involved. It's got a lid that opens and closes with a torsion spring there. So we wanted to test different torsion springs to find out what the right amount was for the weight of the lid. So we had to make this lid weigh roughly the same as what the production lid would weigh. And we could test that back here. Now that's totally isolated from 2 other mechanisms that are in this same product. We have a device up here where if you roll a wheel, it moves something on the inside. We had to check a few different gear ratios to see what the ideal amount of pushes on that dial would be to get it to move a certain distance. It took a little trial and error, and then we ended up proving the concept. Here in the center, we have a separate isolated part where you press down on one end and it pushes up on a button, and you push down on the other button and it pushes up on the first one. So we proved that concept as well. So this doesn't look anything like the final product, but it is useful to get to the next step. Same thing with this one. This one dealt with some fluids that were pushing out of a syringe here. It also has a flexible material right here. This was cast in silicone in-house with the 2-part silicone mix I was mentioning before. And it fits down inside of some rigid 3D printed parts that are all assembled together. Now, some of these parts had to have a high tolerance, which means a very clear, smooth surface. So they were 3D printed with the resin printer. But then some of the more structural, foundational elements, they needed to be stronger and they didn't need as much high definition. So we went ahead and printed those on the standard printer out of nylon. If you look close here, you'll see a bunch of random dowel pins, a few springs, some glue, just whatever it took to learn from this so that it could be evolved into the next version. Okay, so as far as how to test your prototypes, that's going to be up to you and what your needs are. Your test might just be a visual inspection, or it might be a rigorous test that encounters all the exact one-to-one loads that it will experience in real life. You can imagine a block of aluminum that has to withstand 200 pounds of pressure on one part of the aluminum. In order to validate that that works the way you plan it to, you need to make that at 1-to-1 scale out of the right material that you plan on making it in production, and then testing it with the right loads to validate and pass your test. Typically, you want to over-test these products too. I would recommend, especially if it has any kind of load requirements or wear characteristics, to just be pretty brutal with these prototypes. Push them to their limits so that you can find what actually breaks first and how it breaks. That's a super useful thing to learn. We actually have boxes and boxes from past client projects of parts that we made, and then first we did a visual inspection on, and then we had to check the strength of it. And we were pretty rough with it, and sometimes we would be a little too rough and it would break. It would either fragment off or snap into multiple pieces. But it's still very useful to do that because you will see where it breaks. You can then decide whether you want to strengthen that part of the product up or whether you were subjecting it to forces much larger than it would ever experience in actual use, and so you're just not going to worry about it. It's really dependent on your product. There are a few types of testing. I think I'll do another video that's more in-depth on testing, but there's simple testing with the prototypes where you just take some notes, you record them somewhere for future reference, and you use that to build upon. But then there's more advanced testing like destructive testing, which is what I was mentioning before. There's different variations of that, like where you drop something from a certain height. Imagine you're designing a phone case for a cell phone. You're going to want to do a lot of drop testing at different heights with different size phones and different weight phones. There's also wear testing. So you might have to work with a designer or an engineer to build a fixture or a robot that moves something back and forth 1,000,000 times to simulate its use during its actual life. That's pretty common, but it's a little more advanced engineering work to come up with something like that. Just depends on what you need. So some useful places to consider buying your materials and hardware. I've already mentioned Send, Cut, Send. They're really good for sheet metal. There are other sheet metal vendors out there, and if they ever raise their prices and we all need to look for someone else as a go-to, I'm sure there's going to be other people to step in. My favorite place to buy all kinds of hardware, this would be screws, nuts, dowel pins, and tons more, hinges, everything you can think of that's an already created piece of stock hardware. You want to go to McMasterCar.com. They're really good. They're a little more expensive than where you might find it if you found it in the cheapest place. But for prototypes, you just need to embrace the fact that the prototypes are going to be expensive. They're nothing like the cost of a production unit in terms of raw cost. When you get economies of scale, when you make things in the thousands or tens of thousands, they get much, much cheaper than a prototype. So I wouldn't even set a limit in your head for what you're going to spend on prototypes. It's going to be a good amount, but it's necessary. Now, McMaster, even though they're a little more pricey, they have a couple really nice selling features. One thing is they have a massive library of everything you could really ever need. There's very rarely that I have a type of material or type of hardware that I can't find on that website. So that in and of itself is very useful. And it's got a user-friendly design to the website. They also ship you things within 2 or 3 days. They've got locations all over the US, and so they can get things to you real quickly. Downtime is kind of your enemy when designing a product. And so if you design something fully, you place an order, and then you have to sit around for a week waiting for it, that might be lost time, unless you can find other useful ways to spend that time related to the project. The other really big, nice thing about McMaster is that for most of their materials and pieces that they sell, I'd say somewhere around 90%, you can download the 3D part file from the website onto your computer and use it. So in your 3D model, I mean, there's many times when I'm selecting a size of screw that is needed somewhere where I have to download 4 or 5 different screws of different lengths, head styles, diameters, maybe even materials, and then throw them into the CAD model to see which one fits best. Now, your selections will depend on more than what fits best. It might be the cost per part. There's a lot of other things to think about, but that is super useful. I was mentioning before that machine shops are expensive and take a long time to make something. But sometimes it is what it is, and you cannot afford or don't have the capabilities or machinery in-house to develop your advanced part, and so you have to go to a machine shop. If that is required, what I would recommend is formatting your technical drawing in such a way that it is fairly generic, and then sending out what I call a quote request, where you identify somewhere between 5 and 20 different machine shops, and you send them out this email requesting quote on your parts at the different quantities. So if you're prototyping, maybe you only need 1 or 2 or 3 of something made, and so you would ask them to quote at different volume price breaks at 1, 2, and 3. Then when the numbers come back, you decide who to go with based on their lead time, their reputation, and their cost. You might not always go with the fastest person, but there are websites out there like Proto Labs. There's one called Xometry with an X. There's one called Fictive. There's a few others, and they really specialize in getting prototypes made super quick, although they will charge top dollar for it. They're typically anywhere between 2 and 5 times the cost of what you'll find if you do this quoting survey with other local machine shops. But the trade is that you get it done perfectly right and within a week or 2, which is a big difference than waiting a month and a half for something. So, in conclusion, I'd just like to get the point across that prototypes are useful and they're basically necessary to create a high-quality product. You cannot get a perfect product to market without having several prototypes. I would also say no matter what your prototypes look like, I would keep them. Throw them in a cardboard box, put them on a shelf to gather dust, that's okay. There are some times where you go pretty far along the design process and you realize a new constraint towards the end of your design, and that throws you backwards, and you have to take a large step back in the design, and it'd be useful to reference those previous prototypes, because maybe that path, when you chose to go this way, and then you have to take a step back and you want to go this way, you need to see the prototype that was made at that center point. So keep them on hand. Don't be ashamed of them. They don't need to go in a museum one day. You don't need to show them off if you're truly not proud of them. Although sometimes I have seen clients get all the way to the end and bring a product to market, and by the time it hits the store shelves, it's perfect and beautiful and they're happy with it. And they think it's sentimental and it's nice to look back at those super early crude things, those pieces of paper that were thrown together in 5 minutes, because you can say, look how far I've come. I have this beautiful product now, and this is where it started. I mean, I've even had people put their initial proof of concept prototypes, frame them, or put them up in a glass showcase just to kind of smile at it. I think you've heard of people sketching something when they're drunk on a napkin, and then that becoming some big, great idea, and then they frame that napkin. I mean, it's kind of the same idea. Okay, so I've made a lot of prototypes. If you haven't made any before, I'd suggest just diving right in. Don't be afraid. They don't need to look beautiful at first. If you need any help with your prototypes or suggestions on any other parts of the product design process, feel free to reach out to us at availcreative.com. We're happy to help.